doing? Everybody got your pasta and your chicken out there, and everybody has those chairs too. Everybody got their chair and their T-shirts. And of course, we have James Gosling is going to be the main event. Right now, we're going to have a presentation from Gary Collins and myself. We're both engineers, former Sun and now at Oracle. And we're the warm-up for James Gosling. So we're like the warm-up band for James Gosling, who's like the Rolling Stones or James Brown. We're like the Monkees. We're like the new kids on the block. So Gary's like Marky Mark. I'm kind of like the Funky Bunch. But we're here to give the talk on developing with Oracle Java embedded technology for the Raspberry Pi. How many people here have heard about the Raspberry Pi or are currently developing? Wow, jeez. That's probably a good over 60% of the people out here. So that's good. We're going to talk about how you could take today's Java embedded and be able to run on it. And that's, since you're all part of the Java users group, that's probably in your interest. And also, it segues nicely into James's talk, because Gary and I saw his presentation. It's going to be a really good presentation, so stay tuned for that. He's got his demo. He's got all kinds of things with Liquid Robotics, his company that he's at. That it's all kinds of cool things, and you're going to really want to take a good look at that. But as I said before that, we're going to give a presentation on how you can use Java embedded on a similar type of device, Linux ARM, that's called the Raspberry Pi. It's a very popular type of development platform today. And also, we're here to get your feedback. So any type of information that you want to tell us, we'll open it up for questions and answers at the end. After Gary's going to go through a bunch of steps that'll get you there to be running on the Raspberry Pi. And it also applies to other types of devices that are out there. There are the Beagle board, the IMX Freescale boards that are similar. They're Linux ARM. And that's one of the reasons we want to do that, is to allow technology developers out there to be using today's devices to play around with Java. And so before we begin, this is Oracle now, it's not Sun. We have a safe harbor statement, so let's all read this together. So, you know, we have to go through this when we have our types of presentations. But that's, you know, getting past that, here's our agenda for today. We're going to go through an introduction. What exactly is Java SE Embedded? Then we're going to talk about developing with Java for embedded. All these fun devices, including robotics, including small boards that will be able to light up LED lights for you, or drive servo motors for you, or do all kinds of fun stuff. What are the best practices with Java for embedded? Then Gary will take over the presentation, and he'll go over downloading and installing Java SE Embedded platform for your Raspberry Pi. And he'll go through step by step. There's all kinds of interesting details that he's got some hints on how to get around some of the pitfalls that he's seen before. And then we'll have a discussion about that, and finally a demo, and open it up for questions. And we'll make sure to save time for James and his talk. And jumping right into it, the introduction to Java SE Embedded includes that we have a proven and stable platform. It's got a huge developer base that kind of shows the effect here by having so many people come out for a Java talk. And there's rapid application development that you could do with it. You all know, being part of the Java community. It's fully object-oriented, runs on a virtual machine. It's got memory management, portability, and it can be supported on today's multi-core devices. And that's important because Linux ARM now has quad-core and multi-core target devices that are showing up in tablets, in network routers, and all kinds of other devices. So being able to handle that is something inherently that Java can do. There's also, as you guys know, security and high availability networking. And also there's the full Java SE specifications that Java SE Embedded follows. If you know the different additions that we've had in the past, I've worked on Java ME CDC. How many know Java ME connected device configuration? not a huge amount, maybe 10%, maybe 5%. So you guys are more aware of Java SE as one single specification, one set of APIs. We had problems in Java ME because we were a subset of the spec. And so you would have to switch your mindset. Is this API available on a subset, or is it something I'm thinking about that's only available on desktop? Well, we're getting rid of all that. Now Java Embedded has the same exact set of APIs that you would find on Java Desktop. So it'll make you guys happy because you're used to Java SE. And there's also optimizations. You don't want to run the same binary you have on your desktop on these devices like the Raspberry Pi. You want to save on memory. You want to have smaller footprint in terms of static footprint size. So there's smaller persistent ROM and disk requirements, and smaller impact to your volatile RAM, so less dynamic memory usage. Also, there's runtime optimizations in the JIT, and especially for these new ARM compilers. And we'll keep this informal. If you have questions, just wave and shout it out as we go along. Developing for Java Embedded, where is it used? Well, it's used in these embedded devices now, as mentioned, network routers, multifunction printers. There's definitely smaller amounts of memory on them. It might be 512 meg or 128 meg, not the 4 gig that you're used to on your desktop or laptop. And there's lower power CPUs. It's primarily these ARM chips that we're talking about. And you'll find them in robots. You'll find them in these low power devices also. And they're still networked. And as you'll see in James's talk, there's going to be communication that's done with all those robots that are out in the ocean. They are talking a wireless network protocol, and that's primarily what you see with these devices nowadays. And they're either headless or have very small and limited screens. So you have limited types of input, either a touch screen or a keypad, not a full 101 QWERTY keyboard. And this is as much marketing as I'll get. This is where you see it in TVs and cars and everywhere. And this is the typical stack diagrams that you've seen in the past. On one side, you have big servers on the left side, and then you have Java EE that's meant to be run as the key APIs that you have. But you also have the desktop where you can run things like Java FX, and in the future, we'll see that also go to embedded. In the middle, you have the higher end embedded and lower end embedded. And if you look at the blocks for Java, you could see there's Java SE and Java ME meet there in the middle of embedded. So on the lower embedded side, you'll have things like TV, your Blu-ray player, your smartphones and your feature phones, and all the way on the smallest end of the spectrum, on the very rightmost there is your Java card. So what we're talking about now is actually in Java SE, we span down into embedded devices, and it's the higher end embedded devices, such as what you see from James when he's using Linux ARM on these devices that are floating around in the ocean. That's a higher end embedded device. The lower end embedded devices would use Java ME, maybe connected limited device configuration instead. And then tying it all together, of course, as everybody knows here, is the Java language, so that you program it once using the programming language for Java and be able to transfer that knowledge to all these different devices. And what are the best practices? You're going to want to watch your memory just because you have a limited amount. You're going to want to use tricks that we have for reducing static initializers, making sure you're aware every time you're doing a static initializer, that's going to be another burden on the dynamic memory. Also, use lazy memory allocation instead of being eagerly allocating static arrays or just grabbing a huge heap. Make sure to do that only when needed, on demand. And then there's limiting your static footprint size. We have now investigating in our group ahead of time compilation so that your static footprint size or what you need in ROM is going to be the minimal. And then there's limiting use of threads. Even though you're multi-core, you don't want to use everything up. There's the system that's going to be running in the background. So make sure to limit your use of threads. And all this together is dealing with these lower powered CPUs such as the ARM devices. And let's take a look at what you could download right now. And this is what Gary will be showing, is that for your Raspberry Pi, you can go out there and use these product releases that Oracle has already. And if you see the top three, they're all ARM-based types of binaries you can download now. There's ARM v5 support. This is for, has anybody used the Guru plug or the Shiva plug to do Linux ARM development before? Show of hands. Guru or Shiva plug? Not that many, okay. So that's kind of older technology right now. It seems like the sweet spot is the ARM v6, ARM v7 devices, and that's what you see in the second row there, is a Linux ARM v6, ARM v7 headless and headful binary that we support. So you can download that as a Java SE embedded binary and be able to run all your Java programs, compile using Java C, and then be able to copy it over your device as Gary's going to show and show how to run. Then there's also one more. There's a server JIT version of ARM v7, and that's for your higher end type of device. It might be a microserver, it might be something that runs in a data center that's based on ARM. And there's also several other binaries that we have, flavors for PowerPC and x86. So at this point, I'm going to turn it over to Gary, and he's going to step you through the actual instructions for getting Java running on your Raspberry Pi.
So you already know my name. We asked the question, how many here know about the Raspberry Pi? How many have a Raspberry Pi? Pretty cool, about 4 or 5 of us. Yeah, well, we had the same issue, so don't feel bad. We're all in the same line, so to speak. So basically, what I'm going to talk about is the Raspberry Pi. Obviously, the good question, where do you get a Raspberry Pi? Some installation, typical customization stuff that I've found very useful doing ARM. I think we've been doing ARM for, oh gosh, I don't know how many years. And so over the years, I've found a lot of different types of issues that I ran into, and I kind of listed a few of them to make it a little bit easier for people that are jumping into these platforms. And the last, not the last, but how to download. That's the most important. Where do we get it, and how do we download it? And is there Java ready? So then a simple demo of Java running actually on a Raspberry Pi, and we actually have a Raspberry Pi. It's sitting right here, and the demo will be running on this. I don't know if everybody can see it, but so the Raspberry Pi was basically made for try to engage the students to actually learn more, and actually maybe engage us to actually teach more to children, and maybe teach Java on a platform like this. So this is an ARM v6 system, 700 megahertz. It's what we consider an ARM 11, even though it's v6. Has a Broadcom chip for the processor. It also has a Broadcom Video Core 4, OpenGLES 2. I know, 256 mega memory, but I think that's kind of a rich environment for the most part for when you're a headless environment. HDMI, a DSI, composite video, audio jack. The HDMI is actually 1080p with audio out, which is actually pretty compelling for an edge device if you wanted to make something to connect to a TV. 2 USB ports, 2.0 that is, an SD, an MMC slot, an SDIO slot. It has an Ethernet jack, which if you're working in a lab environment, it's, wireless is nice, but when I work in Oracle, wireless isn't nice. And so we recycle our passwords every 24 hours. So having a hard wire to a device like this really makes it easy for us to use in a lab environment and actually for good testing. The awesome 8 GPIO ports for those that would like to turn lights on and off on a little device. UART for interfacing with the device, I2C, the SPI bus. The cool part, 3.5 watts at 5 volts. That's pretty awesome for a small device. Cost $35. I'm sure you guys already heard all of this about the system and shipping. They have 2 models. The first model was the Rev A. They haven't shipped it yet. It has no Ethernet, 1 USB. This device here actually has, again, 2 USB slots and Ethernet. So the other one doesn't. And the HDMI. Next slide. So this is the device. sure most of you all know most of all the stuff on it, but if you look on the bottom middle, that's the HDMI slot. Ethernet is the top bottom right, or top right, as you say. Then you got the USBs, but in the middle is the brains, so to speak. Inside the middle is an ARM core, basically your application processor, also a GPU, and then layered on top of that is your 256 meg of memory. Most systems have them layered on the side. They've actually consolidated space to trim down the device to as small as they can. And the bottom or top left is the GPIO ports. And you can connect even like a simple LCD display to this device as well. Next. So here's where we can get it. If you're in the UK, but you guys aren't. So you'd want to stick with the second one, the RS components group. And so go to there, fill out the, submit your email address, and they'll eventually send you an email saying you're up. And that's about as best you can get. But they're starting to get into production even more, so they'll be a lot more available. And it's a cool device. So I'm not really going to get into how to DD an image onto an SD card. The link there, and again, we'll have a slide at the end which will show a URL to an internal site or an external site that you can follow the guide. There's a more comprehensive set of steps used to actually get Raspberry Pi up and get Java on it and actually do simple testing. So again, the first step there is basically DDing a Debian image, which is what the preferred image at the moment. And it's Debian 605 once you do the first update. Customization steps. My steps aren't always the best for everybody, but for the most part, for my test environment, for making the machines basically a set it and forget it, putting it in a lab and just letting it go, that's kind of what this is towards, usually with the GUI going and SSH enabled. But for the demo, we're not going to have a GUI actually running on the device because there's no cable connected to it. So one of the first steps that I usually do is, when you get this card, I've gone onto the website and researched. Most people stick their card into the device, they DD it, and then they go and take that and they put it into the machine. They're like, I only have 120 meg left. I can't do anything with this. So, and they had a 4 gig starting from. So basically the first step, just resize the SD card. You're actually burning this card from a Windows box or from a Linux box. If you're from a Linux, bring up gparted or your command line if you feel like doing it, and actually resize the partitions. Again, there is a document that will show how to do that, but Google Raspberry Pi or go to either one of those websites that I told, the Farnell or the Allied. They have great instructions on this as well, and pretty good detailed instructions. It's just what we show is what we used. So that's the resize. The fix in the SSH, I found this was usually whenever I get an embedded device from any one of the communities, like Linaro, Ubuntu, or Debian, usually they already have a pre-canned image that you can pop onto these devices. Well, this is the first device I've got from somebody that actually didn't have SSH enabled. And I understand why they didn't. They didn't want to consume more power and consume more space or use more memory. So they didn't start the graphics environment, and they didn't start SSHD. So that command basically will tell you how to launch SSHD as an upstart job, and then you don't have to do anything. I've heard a lot of people actually trying to install SSH, and wait a sec, it's already there. That just shows you how to enable it. The next step was what I found pretty useful when you're here in the US, and where this device was made was in the UK. The image was made in the UK, so changing your time zone, your localization, and your console keyboard settings. I found this useful for Debian. Ubuntu makes it pretty easy, but Debian's a little bit more unique. And I found that while I was trying to edit a file on the etc tab file, and I tried to put a pound key, and I was getting this weird squiggle. I didn't know why. It was a lot of people have found different keyboards not working. It's not a matter of the keyboard will work. You might just have to remap it. And those commands at the bottom there, the dpackage, reconfig, -p locales, and the reconfigure keyboard configuration, those two are the magic to make the keyboard localization all work for your environment, for the US that is. All right, so the next step, they don't start the GUI by default, but the X server actually, so to speak, or the X server is, so to speak, running, but not really running. Doing the changing the init tab. I don't know if you're all familiar with Linux and how easy it is to manipulate it, but these devices are pretty simple. Just change the init tab file, change the init level from a 2 to a 5, and then it will start automatically. A lot of people had to start hacking the gdm.conf files and a bunch of different things. This is simple. Change a 2 to a 5, the graphics starts automatically. You don't have to type start X. Again, I try to make it so in a test environment, it always just works, and it works and deploys across multiple machines. So another one I found useful, and you find this, I found this next step, the static IPing. Of course, static IP is the easiest way to have something managed in a lab environment because I can log into a device because I know what it is, and if it repowers, it comes back up, it's the same IP. In a test environment, it's crucial. For most people, when you're running from your home, you don't need to do that. But the next step I found was very useful, and I find this much of a pain, is the hardware address ether with the MAC address. You pound that into that Etsy network interfaces file when you're using static. What I found in testing over time, the network gets saturated, the I/O gets saturated enough that the system kind of gets confused, and the network resets on you. And so you went from ether 0 to ether 1. And you're like, how did that happen? And someone said, oh, your machine's hung and everything. It's not. Actually, you walk over to the system, it's running. The problem is it rotated itself and went to the next ether port. So doing this has saved me tons of time in a lab environment. And it just makes it, you don't even have to think about it. The next one I found, so to speak, useful. You're in the UK. They're using the UK Debian place. Change the place to the US. It'll be faster for pulling your apt-gets, for installing packages or whatever you're doing. And the last, they didn't enable sound. I would assume it's the same reason. They didn't load the module. So add that to your Etsy modules file, and sound will work on the next reboot, unless you want to do the magic to start it right then and there. But that's about it for that part. All right, so at a nice time, what we try to do in the lab environment is we try to set up systems so they're basically hands-off as much as possible, like a set it and forget it, as less moving parts as possible. Some of these parts are very expensive, and talking $30 to $40 to $60 USB cards, but they don't have a life. They have a very short life if you're writing lots of files to it. So this trick here I found was very useful, using no add time and no dir time on your mounts for the partition 2, which is your root file system. When you actually read on these devices, on these ARM devices, every read is a write. Doing this makes it so it isn't. One, it increases your performance slightly, but it guarantees your life of your device is extended now because you're not doing massive amounts of writes. Partition 3 by default isn't enabled, which is your swap partition. You can use it if you wish or not. I actually enable it in a test environment. It just gives me that extra wiggle room, especially on 256. Actually, there's only 190 available to a user on this particular setup. Last but not least is Iceweasel. It's the browser that I install on the device, at least for Debian. It's pretty reliable. It works well on the ARM system. The Midori default browser, nothing to do with Java. Just you click on the thing, it just dies. Iceweasel works great. Horrible.
Wait. I'm going to just report. Yeah. I'll be repeating the questions. That's my job here. So you were asking about performance, switching to MMC, swapping on MFC.
You want to avoid it like the plague. But it's not good. So you want to try to keep, and like I think Hinkmond said earlier, you really want to manage your memory. And the funny part is, everybody says Java's taking up so much memory and you're executing all this stuff and you're consuming lots of memory. Start the X server up on when you get one of these and launch the graphics server on it. And then before you do it, check your memory, then do it. It's 90 meg, just the graphic environment. So, and the system by itself, default, takes about 25 meg. So you already lost about 115. So you really have to manage your space well. All right, so can I have some Java with my Raspberry Pi? I thought that was a catchy phrase. Glad somebody thought it was humorous. So
it's a tough crowd today,
yeah.
Gary. It's a tough
So
crowd.
you go to that website there. It's the Oracle Network site, and you download Java SE. So the trick for this device is we've always had Java here. It's always been on the website for v6 support for Raspberry Pi. A lot of people in the forums have said there isn't any Java on the Raspberry Pi. How do I get Raspberry Pi for Java? And a lot of people will just apt-get, and they install OpenJDK, and they say, oh, it's not really that fast. And they're probably right. So where do you get a performant Java? This website here, you go to this website, click on it, download the ARMv6 headless version for this device. It's an EABI VFP with soft FP ABI. I don't know if you're probably all familiar with that, with little endian. So fill out the questionnaire. Well, I heard somebody at the dinner tonight said, what's up with the questionnaire? Why do I have to answer questions? And I said, well, for us to be able to predict the future, we need information from you to help us know where we're going to go in the future. So the more information you provide, the better we can in predicting where we're going to go next to make sure that we're giving you what you need to do your next greatest thing. So once you fill this out, obviously you're going to have to do this from a Linux host box, unless you really want to set up a mail system on a Raspberry Pi and send your email back to that. But you can do it, and it does work. But from your host system, you're going to get an email. Click on the email once you're all done submitting, that is. And this is the download you're going to actually download, the ARMv6 Linux headless, very specific, the EJRE and this version here. And that will work perfectly fine, the headless environment on this device. And it works. So next. So I'm sure you guys all know about tar.gz files, and so our bits are basically tar.gz'd up. There's not an RPM or a package to install. It's basically a tarball that you would put onto device. So I don't know if everybody knows all those commands, but it's basically simple Java and simple tar.gz commands to pop it on. So I guess we're going to go into the demo now to show the Raspberry Pi running a simple Java program. It's just basically a server socket program running on the Raspberry Pi. And what it's doing is it's opening up a port on the Raspberry Pi and basically communicating bytes back to a web browser through some port. And it's actually going to be communicating back to the Mac to show in the browser.
Did you want to talk about the type of data it's grabbing? It's the CPU info, right?
So basically, the system, it's a Java program that's basically in the background is doing a bunch of pulling of different files and property information from the system itself and is sending it back. It's not awe-inspiring, but the point is, it's Java and it works on the device. I could have shown you a really cool demo, but I figured I'd leave it for James, and he can show a really cool demo on his device. But this is a simple Java program running hardware status.
So you might want to point out this cursor and this prompt is on the Raspberry Pi
Yeah,
itself.
so the left screen is basically the Raspberry Pi. If you can see the process, we did a cat proc CPU info. You'll see it's an ARMv6 compatible device. It's 697 megahertz or 700. They call it BOGO, but that's basically megahertz. And it's a Broadcom 2708 chip. And it's a Type 2, and I'm not sure what why it's revision 2, but.
Okay, so I'll just start up the jar demo, right? So this is the Java that Gary talked about downloading directly from the Oracle OTN website. And then you just untarred it, and now we're just going ahead and run it. So it's starting up. It's going to open up a port and start communicating on that port. Now, do you want to talk about the browser we have open here?
So basically the browser, we obviously, if you notice that the time is there, it's a fictitious time, obviously, because I didn't do NTP date. I usually, for myself, I always drop inside the etc local file. I don't know if you guys use that at all. I actually add little commands and different things, and a lot of the ARM device people will actually drop a lot of information in there to query the system. And in this instance, it actually queries for the IP, and the IP is sent back, so then you can see what you need to SSH into if you're attached with the monitor. But basically, this one here is showing you the time, the last time it was running, which was 4:10, which was a long time ago today. And you'll see the memory, and you'll see it's the chip. So now he's just going to basically reload the page from running, and it's actually going out and connecting. As you can see, it connected to the system, and then the time actually changed. It's not really the real time because I didn't set the date. So it shows the price.
Let me Control-C this and,
Yeah.
and just show people that it's actually trying to communicate to the Raspberry Pi, because
Yeah.
now
So
if
now
I
it won't.
Control-C it,
Yeah.
won't. But then I start it back up again. Gets on that same socket, 5000.
And you reload again, a client
Reload.
connected. I
And
mean,
there it is.
I don't know how else to show it, but I mean, I can pull the network cable out and show you. But basically, this is the device here, and Java runs, and it runs great on it. So go get yourself one and start playing around. I mean, it's for $35. You can't beat it. I mean, it's just amazing.
So oh, thank you. Hey, you got applause for a demo. That's pretty awesome.
Thank you.
So we're just going to have a discussion now, and then we'll open it up for questions. So if you guys can queue up and think of any questions that you might have for Gary or myself. That program that you ran, it's a jar file that's from Revolution Robotics, is that right?
Yeah, sorry. I should have done a thankless plug to Aaron Moore from Revolution Robotics. He basically wrote a really cool demo, but he gave us a bunch of different pieces from that. We put it all. He basically put it all together in a NetBeans project and made a few modifications, which we showed on the screen. But basically, he did most of all this work. We're just utilizing this. This code, by the way, will actually you can be able to download it. We'll have we'll try to update our site where it explains in more detail of how to get a Raspberry Pi up and running pretty quickly. So on that site, we'll try to put the link at the bottom maybe to reference where you can download from Revolution Robotics this code.
And another question that people might have out there right away is if you have your .c source, .java source file and you want to compile it, what is the way that you're supposed to compile it and then get it onto the Raspberry Pi?
So in this case, we have a JRE on the device, so there is no Java-C. And typical deployments for embedded devices is you build it on your really cool Linux or Mac or some device, compile it, and deploy it. It's Java, it's class files, you just drop it over there, and it executes. Where you bridge the world is with a little bit of JNI, so that's where you have to be a little bit more creative on how to actually cross-compile your native code to work on the ARM device, and then merge the two together and then deploy.
So here's the resources that Gary talked about, and we'll have these available for anyone that wants to come up after James's talk and have questions for us. But we'll also make the presentation available to people too.
Yeah.
And there is, at the very bottom, there's a getting started guide that will sum everything up there.
So that's a more in-depth. I went really quick and I really didn't go into detail. And we're going to try to build on a better resource, so how to really get up and going on an ARM device. I mean, I've run into so many different types of issues, and I've hit my head against the wall so many times. And so basically, you really want to make and minimize as much of the scope out of developing on these devices and make just pure Java, and that's what you're trying to worry about.